When we look up at the night sky, every star and every galaxy we see lies within a bubble, the observable universe. It's a sphere centered around us, stretching 46.5 billion light-years in every direction. Beyond that distance, the light from objects hasn't had time to reach us since the Big Bang, which happened 13.8 billion years ago. But if the universe is only that old, why can we see 46 billion light-years away? To understand that, we need to explore not just space, but time itself. Right after the Big Bang, the universe expanded at an unimaginable rate, a process known as cosmic inflation. Space itself stretched faster than the speed of light, carrying galaxies away from each other so rapidly that even light couldn't keep up. That's why the observable universe today is much larger than 13.8 billion light-years. The light we see from the farthest galaxies began its journey billions of years ago when the universe was young. But during that time, space itself has been expanding, stretching that distance far beyond what we might expect. What's fascinating is that the observable universe isn't a physical boundary. It's more like a limit of perception. It's the farthest point from which light has had enough time to reach us. Beyond that limit, galaxies still exist. Space continues. But because their light hasn't arrived yet, we can't see them. Not now, and possibly not ever. The expansion of the universe is accelerating, which means distant regions are being pushed away faster than light can travel. Those galaxies are slipping beyond our reach, forever hidden. Suppose you could somehow travel to the edge of the observable universe and look around. In that case, you'd see your own Milky Way at the edge of your observable universe. In other words, every point in the cosmos has its own observable bubble, and they all overlap. There's no true center, no edge where the universe ends. It just keeps going. What we see is merely our slice of infinity. But what lies beyond what we can see? One possibility is simple: more of the same. Galaxies, stars, and matter extending endlessly. But there's another possibility: that the universe is finite but unbounded. Think of it like the surface of a sphere. You can travel endlessly in any direction without ever finding an edge, yet the total area is limited. In this case, the universe could loop back on itself. If you traveled far enough in one direction, you might eventually return to where you started, not through space, but through the curvature of space-time itself. And then, there's the most radical idea, that what lies beyond isn't part of our universe at all. According to the multiverse hypothesis, our universe might be one bubble among countless others. Each bubble could have its own laws of physics, constants, and even dimensions. These universes might collide, interact, or remain forever separate, floating in a higher dimensional space we can't even detect. The more we learn about the cosmos, the more humbling it becomes. Every telescope, from Hubble to James Webb, has expanded our cosmic horizon, showing us galaxies formed just a few hundred million years after the Big Bang. But even these telescopes can only show a small fraction of what's really out there. What lies beyond that edge may remain forever hidden, unreachable even by the most advanced civilizations. Yet, this boundary gives meaning to our search, because every photon that reaches us, every faint signal from deep space, is a whisper from a time when the universe was still young. The edge isn't a wall. It's a reminder that no matter how far we see, there will always be more waiting in the dark. So, what truly lies beyond the observable universe? We may never know the answer, but perhaps that's what makes the cosmos so breathtaking. Because the universe doesn't just challenge what we know, it challenges what we can know.